G'day, I'm Mr. Husband and welcome to a flip lesson on cross sections. Today we're going to look at how we can use a cross section to do a visual representation of a topographic map. So for those who haven't looked at contour lines before, let's have a quick recap on how a contour line is constructed. So if you can imagine an island surrounded by water, the actual outline of that island would be 0 meters, and as the sea level goes up we could draw a new coastline. So looking at it after the water's risen by 10 meters, you can see a new line there. We go up to 20. Okay, we keep going up, and as we're going up we could draw a line around the new coastline. So this is what would happen under rising sea levels, but we're just using this to show how the contour lines actually look on a map. So you can see that on this map now we have two distinct mountains and we have a set of 5 contour lines. So 50 meters at the top, 0 meters on the bottom, 10, 20, 30, 40. So the contour interval here is actually 10 meters because that's where we're deciding to draw each contour line. We could do a contour line at 1 meter or 2 meters, but then the island would be full of lines. So it's important that we choose an appropriate contour interval to show us enough detail to get a look at the representation of the mountains, but not too much that it just fills it in with lines. So with our contour lines, the closer the lines are together, the steeper the slope. So if I took this topographic map here, I can then draw a cross section using that map, and I can actually put that straight on my page and draw it down, but we're going to show you how to do it properly off a map in a second. So a cross section just basically looks like this. We're going to have a graph, and we're going to have height on the left hand side and distance along the bottom. So if you take the map, and you should have this mapping in class today, or if you don't, if you're doing this for homework, you'll be given this map in your next lesson. And we're going to take this map, and let's say I asked you to find the distance between Mount Erin and H. You take any scrap sheet of paper, anything with a straight line, preferably white with nothing on it, so you can mark it, and then you get a pen and you mark off each of those lines. You also mark off features. I usually do my features a little bit longer so I can distinguish them. Now some people, when they do cross sections, don't worry about the features, but I think it's a good idea to put them in so we know where things are on the map. Okay, then I type in, I write in the numbers. So when I look at those lines again, I know that that's going to be 400 there, and the next one's going to be 350, and so on, and I go all the way across there. I also put in things like river, rail line, roads, etc. So after you've done that, you end up with a piece of paper with all those features on it, with each of the lines. Being careful you get the right contour line. Sometimes you have to move the paper away and put it back again to see the numbers on the lines. And we're going to get a piece of paper which looks like this. Okay, it's going to have all of the details on it. And I put this on the bottom of my graph. Now you draw your graph in your book, and you pick an appropriate set of distances up here, so you make sure that you cover all the height you need here. So the highest point I have here is under 500, so I know 500 can be my top. I then take a ruler and I don't know the exact height of Mount Erin, but I'm going to guess it's around about, I don't know, 450. So I'm going to mark a point there. I take my ruler again. I move it across to 400. Now you can do this with or without a ruler. I just think it's a bit more accurate if you draw it straight up. And so on. Until eventually you get a series of dots, and you can then join those dots all the way up. Okay, so using those rulers, plotting those points, and then drawing them along. So you can do that in your book, and you'll be given a map extract to do that. Moving along, we also need to make sure that we understand that we are actually exaggerating the height of these mountains on our graph, because our vertical scale is not always the same as our horizontal scale. We do that so we can actually show areas properly. Now, if we have a contour interval of 50 and we have a scale of 500 metres, if our horizontal scale is 1 centimetre and our vertical scale is 1 centimetre for every 50 metres up, then we need to make sure that we tell the person looking at the graph that there is actually a vertical exaggeration. In this case, we take the vertical scale of 1 over 5,000, divide it by 1 over 50,000, invert and multiply to get 10. So what that figure 10 means is that the mountains on our graph are actually 10 times higher than they would look in real life. But if we did it as they looked in real life, our graphs would have very little, would give very little detail to the viewer so we could see them. Now try this. There'll be a question on this in a second, and I'll show you the answers after you've done the question. Okay, let's have a look at the matching activity contour pattern answers. I hope you got these right. We'll have a look at number 1 first. Number 1 has steep side to the west and to the east, a fairly gentle slope. So we want something where the contour lines are close together here and further apart on the right hand side. And I think D matches that one perfectly. Okay, A, we've got our gentle slope on the left, bit of a flat top at the top. So I think B matches 2B. I'm going to skip 3, I'll come back to that in a second. But 4, you want something where the contour lines are fairly even on both edges with a point at the top. And there's F, there's our man. Number 5, you've got a smaller mountain on the left and a taller mountain on the right. So 5 is A. Now we have our 2 similar looking mountains. They've both got 2 hills, but one of them goes down deeper in the middle, which means it's going to have more contour lines around each of the hills. So it's a bit shallower here, whereas this one here, the actual mountains themselves don't stick out quite as much. So E must be 3 and C must be 6. There you go. Hope you did well.